Okay, so without further ado, I would like to reintroduce our headline speaker for today, Dr. Maya Abou-Zeid, and she's going to be talking about subjective well-being and travel and behavioral insights and integration with choice models. The floor is yours.
Thank you, Giancarlo. Thank you to you and Cara for inviting me to present at this conference. I'm thrilled to be here. And as you mentioned, this topic of subjective well-being was the focus of my PhD dissertation. And I continued to do afterwards a series of studies related to this topic, which I will be describing in today's talk. I will start with an introduction and the background about the topic of subjective well-being and its linkages to transportation. And then I will describe 3 studies. The first one is on commute satisfaction. The second one is on activity happiness. And the third is how satisfaction indicators can potentially be integrated with choice models to improve choice models. And then I will conclude with some main takeaways and some directions for future research. So how is subjective well-being defined? It is defined as how people evaluate their lives from their own perspectives. And it has 2 components, a cognitive component, which is a global assessment of people's satisfaction with their lives and its different domains, and an affective component referring to how people feel about their lives. So sort of the emotions, the positive and the negative. One example of that, for instance, from the World Values Survey, they ask this question, taking all things together, would you say you are very happy, rather happy, not very happy, not all happy, or don't know? There has been a lot of interest in measuring subjective well-being, both at national levels as well as globally. For example, in England, they conduct the British Household Panel Survey repeatedly, and they include satisfaction measures in it. Similarly, in Germany, there's the German Socioeconomic Panel. There is the Eurobarometer in the EU. In the US, there's the General Social Survey. We also have the OECD Better Life Index. Globally, there is the Gallup World Poll. And interestingly, in Bhutan, since the 1970s, they have introduced this indicator called the gross national happiness to track their citizens' happiness over time, in addition to tracking standard measures of economic and social progress, such as GDP. There has also been a proliferation of books on the topic of happiness or well-being. These are just 2 of my favorites, Well-Being, the Foundations of Hedonic Psychology by Kahneman et al., and Stumbling on Happiness by Daniel Gilbert. There are also many others. There's even a journal dedicated to this topic, known as the Journal of Happiness Studies. So the question is now, why is subjective well-being relevant? Why is it important to study? First, there's an intrinsic value of subjective well-being because it correlates with human functioning. In general, when people are happier, they perform better in different domains of life, such as marriage, income, and health. It's also important to study subjective well-being, to monitor trends in society. Are people, for example, becoming happier or less happy over time, say, as income is increasing? It's also important to identify vulnerable or problem groups in the population. For instance, people who are less happy, and try to identify the causes of that and improve their happiness. Subjective well-being has also been studied in the context of trying to understand the correlates or the drivers of subjective well-being and how people make decisions in relationship to their happiness. And finally, for guiding policy, for instance, trying to help policymakers prioritize certain policies that have a bigger impact on well-being, such as in healthcare or poverty reduction, for instance, and also to use it as an additional measure of progress in addition to GDP. What are the determinants of subjective well-being? These are broad categories of variables that have been found to correlate with subjective well-being. The first category is demographic variables and personality. As an example of a demographic variable, interestingly, it has been found that age has a U-shaped relationship with happiness. We tend to be happier when we're younger or older and less happy around the middle age. Personality also is correlated. For example, people who have extraversion typically are found to be happier. Socioeconomic life events and lifestyle variables also play an important role. For instance, income as a socioeconomic variable, life events like unemployment, marriage, disability cause decreases or increases in happiness. and lifestyle variables, basically how we use our time. And I will come to this in a moment. Comparison processes, by human nature, we tend to compare ourselves often to others, and people who are doing better than the average tend to feel happier, for example. Sometimes we compare our current situation to our previous situation as well. And if we are now doing better than before, we tend to feel happier as well. And finally, interestingly, there is this process of adaptation and aspirations, and in particular, this process of hedonic treadmill. So the idea here is that sometimes certain life events, say marriage or disability, or maybe winning a lottery, can change our happiness momentarily. For example, you may feel very happy when you win a lottery, but as time goes by, you adapt to your new conditions. And the idea is that people have a baseline level of happiness and they return to that baseline or set point level of happiness. So this notion of hedonic treadmill has been found for both positive and negative life events. And I will be revisiting it in one of our studies on activity happiness. So as I said, time use has also been found to significantly correlate with happiness. There have been a variety of studies done to understand how happiness varies by activity type. This is one classic study from Kahneman and Kruger, which was done with a sample of employed women in Texas. They measured a number of emotions that are experienced during different types of activities. And they have different indices for that, the net affect and the U index. And they found this is the ranking. They're sorted by activity from increasing order to decreasing order of happiness. And activities that involve intimate relationships or socializing after work or relaxing tend to be in the highest happiness categories, while interestingly, the evening and the morning commute to work are among the lowest happiness, the activities that cause the least amount of happiness, and working as well. There are also different timescales to measure subjective well-being or happiness, and this is important because it can have an impact on the measure that we got. One can ask about remembered happiness, so it's sort of like a retrospective evaluation of happiness, and this can be subject to recall bias because we are remembering something in the past, and people often do not necessarily focus on the entire experience, exactly how it went. They may focus on particular moments of the experience. There's also the notion of experienced or moment happiness, which refers to a real-time measure of happiness as the experience is going on, assuming one can get such measures. And predicted happiness, which is when people try to make a prediction about how happy they will be with different, say, courses of action. And this is relevant, for instance, in the context of choice models, and it's correlated with the notion of decision utility. Now, I would like to talk a little bit about the linkage between transportation and subjective well-being before I start with my 3 studies. So there have been different frameworks put forward to link how is transportation related to global subjective well-being. This is one of them by Etema et al. One important pathway for the relationship between travel and global subjective well-being is through its enabling of activity participation. So transportation is a derived demand. We travel typically to conduct activities. And when we participate in activities, we satisfy our daily needs, and this leads to a sense of global or subjective well-being. People who don't have the chance to participate in daily activities, for example, outside of their home, may have a social isolation. So the idea that travel enables activity participation leads to subjective well-being. Another pathway is through the notion of stress or time pressure. Sometimes when we make trips in stressful conditions or when we feel time pressure, that can decrease subjective well-being. And finally, the conditions in which we travel, the affective factors and the instrumental factors like the safety, the cleanliness of travel, crowding, comfort, and travel time and cost can also affect travel well-being and consequently subjective well-being. There has been a lot of research on subjective well-being in transportation over the last 10 to 15 years. Some of this research has focused on these kind of theoretical frameworks. There are other examples in the literature. A lot of it has focused on measurement of subjective well-being in transportation and trying to understand the causes of satisfaction with different modes, for example, of transport and how they compare to each other. as well as with activities. And finally, some of the literature has focused also on integrating happiness data with choice models. So given this background, I will now start with the first study, which I did with my master's student Zahwa Al-Ayash on commute satisfaction in a developing country context. So the research question that we tried to pose here is whether car users who regularly go to work or to university by car, would they underestimate their satisfaction with public transportation if they were to use public transport as a regular commuting mode? And the relevance of this is that by understanding that, we can try to design policies which are aimed at increasing public transport ridership by trying to attract car users to public transport. The context of this study, it was conducted with a sample of 734 students and staff of the American University of Beirut in Beirut, Lebanon. It's called AUB, using 2017 survey data. Just to give you an idea of the context of the city, car is the dominant mode of transportation over there. Around 80% of motorized trips are made by car. The rest of the trips are made by public transport, which consists of two modes, bus or minibus, and jitney, which is sort of like a shared taxi. And public transportation operates as an informal mode of transport. It's informal public transport system. It's unregulated for the most part by the government. It has, for instance, no fixed stops. This is an example of a minivan circulating in Beirut. So we conducted a survey and we asked 3 satisfaction measures. For car users, those that regularly come to the university by car, we ask them 2 satisfaction measures, H1 and H2. H1 refers to their commute by car. So taking all things together, how satisfied are you with your commute by car between your residence and AUB, the university? And H2 is in reference to an infrequent public transportation commute, which they have done in the past year. So in the past year, how satisfied were you with using public transportation modes like taxi, service means this jitney that I mentioned, or bus and van to go to the university? And these were answered on a 7-point scale, going from very dissatisfied to very satisfied. So again, H1 refers to the regular commute by car, and H2 refers to an infrequent public transportation commute for car users. For those that come to the university by public transportation, we ask them how satisfied they are with their commute by public transportation between the residence and AUB, and we call that measure the H3 measure. So what's our approach? We develop models that try to explain H1, H2, and H3 as a function of covariates. So what causes these different levels of satisfaction? So we try to estimate the betas, and once we have those models, we apply them but only to car users. So we apply these models to the sample of car users to get their predicted H1, H2, and H3. So we want to use the model which was estimated on the public transport users. We apply it to the car users to see if they were to switch to public transportation as a regular mode, what is their predicted level of satisfaction with public transportation? So this is the idea. And then we want to compare how that prediction of H3 how does it compare to the predicted H2? Basically the regular commuting with PT as a regular mode versus commuting with PT as an infrequent mode. So I will show you briefly the estimation results and then the model application. So these are ordinal logit models because the responses are on a scale of 1 to 7. For H1 and H2, we developed a joint model because they are obtained from the same sample of car users, so they could be correlated. This top part here is the results for H1, and this is for H2. Satisfaction with private car for car users, so this is H1. We included cost and time variables, and both were negative and significant. So as cost and time increase, people would be less satisfied with their commute by car, as has also been found elsewhere in the literature. We found that staff members, as opposed to students, are less satisfied with their commute by car. For the remembered satisfaction with public transport as an infrequent commuting mode, we found that also cost and time matter, and they are negative. But for example, some of the variables turned out to be insignificant, like the cost variables. So people did not, maybe they were not so cost sensitive, in this case, the car users, to the cost of public transportation, which is their infrequent, that's not their regular mode. We also had some socioeconomic variables like households with 3 or more cars as a proxy for income, and we found that people with higher number of cars are less satisfied with public transportation. We included an unobserved error, a correlation term between the H1 and the H2, because these are responses obtained from the same persons, and it turned out to be significant. For the H3 model, briefly, this is also estimated on public transportation user sample. We also have cost and time. We broke down the time by bus or time by jitney. And we found that they're all negative and more significant than the case where public transport is an infrequent mode of commute. So when people use public transportation as a regular mode, they are more sensitive to cost and time in terms of their influence on their satisfaction. Staff members seem to be happier with their commute by public transport compared to students, and those that live within the city boundaries seem to also be happier, probably because of a better service within the limits of the city. So now that we have these two models, these are the betas, we apply them, as I said, only to the sample of car users. And once we do that, we can get for every person their predicted H1, H2, and H3, and then we average that. And these are the averages across the sample. So we find that on average, out of a scale of 1 to 7, as I said, the expected satisfaction with the car is 3.71 over 7. The satisfaction with an infrequent public transportation commute is 2.87, and that with a frequent public transportation commute, meaning if the car users were to switch to public transport as a regular mode, their expected satisfaction is 3.4. And using some statistical tests, we found that this H1 is significantly different from H2 and H3, and H2 is significantly different from H3. So this shows that it seems that if the same car users were to switch to public transport as a regular mode, their satisfaction with public transport may increase. This figure here shows the same conclusion, but looking at the distribution instead of just averages. The red columns, for example, show the distribution of the H2 measure, while the blue columns show the H3 measure, and we see that there is a shifting of the distribution to the right. So people seem to be more satisfied if PT was to become their regular commuting mode. So what are the main takeaways from this study? The first is that car users are more satisfied with commuting by car than with public transportation as a regular mode. And this result has been found also in other contexts. It obviously depends on the context of the public transportation and the commuting by car in the city that's under study. But we found that also in Lebanon, where public transportation tends to be informal and unregulated. And more interestingly, we found that car users experience satisfaction with public transport may be higher if it were a regular commuting mode than an infrequent one. What are some potential explanations of this result? One is potential misperceptions of public transportation attributes due to infrequent use. So maybe these car users, because they don't use public transportation frequently, they may misperceive some attributes like time, say, or cost. So by having it as a regular mode, they will know better what the different attributes are, and they may be more satisfied with it. Another potential explanation is rationalization of the choice of the regular mode. So often people rationalize their choices to reduce cognitive dissonance. And so that as a result, their satisfaction with their actual choices may increase. And finally, an effect that we did not account for here, which is potentially, self-selection. The idea that the H3 model was estimated on a sample of public transport users, which maybe by nature may be more inclined to use public transport than the other sample of car users. So this is also a potential explanation for why the H3 measure, the predicted value, could be higher than the H2 measure. Obviously, maybe a better way to do the study would be to do a natural experiment where you track people over time, a sample of car users that switch to public transport and measure their satisfaction with public transport before and after, but that's not very easy to do and more costly. So this was done here using modeling. Okay, So I will move now to the second study on activity happiness. And this study I conducted in collaboration with researchers from MIT and from the University of Melbourne in Australia. The research question that we posed here is whether people perceive activity happiness the same way as they experience the activity in real time and retrospectively when they remember it later on. And why is this relevant? It's relevant because it has implications on how we measure activity happiness. Is it better to measure it in real time or retrospectively? Are the answers likely to be different? So the methods that we use to address this research question are the following. As a measuring platform, we use the Future Mobility Sensing, FMS, smartphone app, which was developed by a team of researchers in MIT and Singapore. And this app includes a web validation tool for users to validate their activities and travel. Using this app, we included happiness measures, as I will show you next. And after that, we did modeling. Using the data that was collected, we did dynamic ordinal logit models of activity happiness. So this is how the Future Mobility Sensing FMS platform works. The app, the smartphone app, relies on data collection from 4 sensors: Wi-Fi, GSM, GPS, and accelerometer. The raw data that is collected passively through the app is sent to a server, and there are some machine learning algorithms that process this data and try to infer where the person went on a particular day, the stop locations, as well as the times of day, the modes of transportation used to reach these different activities, the activity purposes, and the accompanying number of persons. This last one is obtained by asking the users. So there's a user interface like this, where people see on a map the different stops that they conducted over the day. And then they see a list of these stops, 1, 2, 3, etc., with the purpose of each stop using an icon like home, changing mode, etc., and the time at which the activity was conducted, and the mode of travel between any 2 different activities, whether it's car or walking and so on. And so people can validate these activities. They can confirm if the attributes have been correctly inferred, or they can correct any attributes that have not been correctly inferred. So what did we do? We added a real-time happiness question on the phone. So at a random moment during the day, after we have detected movement on the phone, there was a prompt on the phone for including a happiness question. In fact, we had 2 questions. One is about the current activity of the person. What were they doing at the moment that they got the notification on the phone? So they select home, shopping, picking up, dropping off somebody, work, traveling, etc. And at the same time, we asked them, how happy are you with your current activity? So just 2 questions. And it was a 7-point scale going from very unhappy to very happy. We recognize that not everyone would like to answer a question in real time on their phone. They may be busy or do not want simply to answer the question. So we did not remove the question if it was not answered. It stayed on the phone until the next day, until another question was available the next day. But in any case, if no response was detected within 30 minutes from the moment the alert popped up, the question then becomes, how happy were you with your activity X hours ago? So we call this the real-time happiness response. And at the same time, for the same activity, this one for which they answered the real-time happiness response, when they come to validate their activities, like here on this interface, for that same activity, we ask them, how happy were you during this activity? So this is the retrospective question, which they answer when they come to validate their activities later on. It was also a 7-point scale. This is an old version here showing a 5-point scale, but we then switched it to a 7-point scale. So we have the real-time measure and the retrospective measure. And to give you an idea of the context, so the data collection happened with students and staff of the University of Melbourne in Australia. It was a 14-day data collection period per respondent. In fall 2015, we had 114 users conducting or reporting 1,213 different activities. And and there were 1,733 happiness responses. Not everyone answered all happiness responses for both of them. So that's why the number of happiness responses is not double the number of activities. We found actually that 43% of the happiness responses occurred within 1 hour of the activity itself, and the rest, or around 90%, occurred within the same day, within 24 hours. Now some descriptive statistics. This slide here shows how happiness varies by activity type. So we have 7 activity types: home, work, we grouped some of them: home, work, education, personal business like doing errands, discretionary activities, social, recreational, travel episodes, and other. And the red bars are the very unhappy or unhappy categories, and the blue ones are happy and very happy. So in general, if we look at all the different activities, in general, most responses tend to be in the happy category, around 71%. And this is to some extent consistent with Australia being one of the happiest countries in the world, and in particular, Melbourne being a very livable city. We also find that, also consistent with the literature, that discretionary activities and other activities tend to have the highest percentages of happy responses, while education in this case tended to have the highest percentage of unhappy responses. And then given this data, we developed a model. What we did is, so we're trying to understand, we want a model that helps us to understand what causes these different activity levels and whether the real-time activity measure is different, happiness measure is different from the retrospective measure. So what we do is we associate a set point or a baseline level of happiness, of activity happiness for every person. How do we define the set point? It's defined as the median of the reported activity happiness across all activities. So say, for example, a person had reported happiness levels for 15 activities. We take the median of these happiness responses and we consider that like their baseline or set point level of happiness, which we assume to be stable over the data collection period, because given that it's only a 14-day data collection period. And this notion of taking the set point as the median is also consistent with the literature of the hedonic treadmill. And then we model the hedonic state, which we define as the deviation of the activity happiness from that set point. So we have the set point for every person, and then we take the difference between the reported activity happiness and that set point, and we model that difference as a function of activity attributes. For example, the type of the activity, the duration of the activity, or whether it happened on a weekend or a weekday, and as a function also of socio-demographic characteristics using dynamic ordinal logic models. So we have the happiness responses, the DNA1 and DNA2, or more specifically, the deviation of the happiness responses from the set point. And these ranged from -4 to +3. And as is typical in ordinal logic models, there is an underlying latent response variable. So D is observed, H is latent. So the underlying latent response variable causes the observed one. Similarly for, so DNA1, sorry, I didn't define it as the happiness response, the real-time one, and DNA2 is the retrospective one. So each of them, for each of them, there's an underlying latent response variable. And we assume that the first happiness response influences the second happiness response, because after all, this is the same activity. So there should be some sort of correlation or causality between them. And then we develop models that explain these H's. So H and A1 is a function of the attributes of the activity. So X and A1 are the attributes of the activity and the socio-demographic factors multiplied by some betas. We include a panel and error component to account for the panel effect, because this same person provided several happiness responses, and another error component specific to the real-time happiness response to account for potential errors in answering the happiness question on the phone. And finally, an independent disturbance term, which we assume to be logistic. And this first component here, just excluding the epsilon, we call it this H and A1. It is what we assume to influence the second happiness response. So H and A1 times a beta So the second happiness response is influenced by that. In addition to that, we assume that the observation time, I mean the time until the person answered the second happiness response, may have an influence on their answer. So we included that as an explanatory variable as well. And finally, an independent error logistic term. So the epsilons are logistic, so that results in an ordinal logit model. And these Ds are related to the H's through threshold models. And conditional on these error components, the probabilities of DNA1 and DNA2 are logistic. To get the unconditional probabilities, we integrate over the distributions of eta and omega. I will not show the detailed model estimation results. I will comment on the main insights and show you some figures and some estimation results, just briefly. We find that activity type, the duration of the activity, and whether it's conducted on a weekday or a weekend, influence activity happiness. It turns out that socioeconomic variables in this case are less significant. Interestingly, we find that the answers the happiness answers which are given in real time tend to be more positive than the ones which are given retrospectively. So there is an evidence for an intra-activity hedonic treadmill. Remember the notion of the hedonic treadmill that I mentioned at the beginning of the presentation, which is that people adapt to the new conditions as time goes by, and their happiness level goes back to their baseline or set point level of happiness. So that was found for life events in general in the literature, or for certain types of unpleasant activities. So here we find something similar for daily activities that we do on a day-to-day basis. In other words, what this means is that people tend to remember their activity happiness as more neutral as time goes by compared to the real-time happiness answer. This figure here shows us the happiness level for different activity types, as well as how happiness varies by duration of the activity for activities that are done on a weekday. So home is the base, the reference. We can see, for example, if we just look at the intercepts, if discretionary, which is the purple one, or other activities tend to be the happiest activities. So the activities which are least happy in this case are work, this one, travel, the blue one, and education. In terms of how they vary with duration, in general, we found a slightly increasing effect of activity happiness with duration. It's sharper increase for discretionary and other activities. There is a decrease in activity happiness with duration, but not very steep for work activities and education activities. These were quadratic functions of activity duration. This is the result that I mentioned before. This is the parameter estimate for the effect of the first happiness response on the second happiness response. So it is positive. Obviously, the two have to be correlated. I mean, if the first happiness response is positive, the second, it would be, I mean, strange to have it as really very negative. So they are correlated, but as you see, the parameter estimate is less than 1, and it's significantly less than 1. This means that there is a damping effect or an evidence for an intra-activity hedonic treadmill. So as I said, the individual's perception of the happiness towards an activity instance is likely to become more neutral as time goes by. What are some of the limitations here? We assume that there is one set point across all activities of a given person. One can potentially model different set points for different activity types, but that requires having more data. The model here also does not account for sequences of activities. Maybe I feel, for example, happy or less happy during an activity because of some carryover effect of another activity that I conducted before. So this was not accounted for here. And there's also potential self-selection for this particular sample of users in terms of how happy or unhappy they are to start with. Okay, so I will now move to the last study, which is a bit maybe more brief than the first two. And this is the how we can integrate satisfaction indicators with choice models. And this is also based on work with MIT collaborators. So the research question here is, how does the addition of happiness measures impact random utility choice models? Would it be beneficial to add satisfaction or happiness indicators to choice models? This question, the relevance of it is because if we find some benefits, then it may be worth adding some happiness questions or satisfaction questions to household travel surveys, which are already quite long typically, so in case they give us better choice models by doing this addition of happiness indicators. So this is a framework for an extended random utility choice model that we have proposed during my PhD thesis together with Professor Moshe Ben Akiva. This is the standard choice model where you have the utility of different alternatives influenced by some explanatory variables and reflected through choice indicators through utility maximization. So the utility of alternative I is a function of the attributes of alternative I plus some random disturbance term, and yi is the choice indicator. You choose alternative I if the utility of I is greater than or equal to the utility of all other alternatives, and it's 0 otherwise. So this is utility maximization. So what we did here is we added, in addition to the choice being a measure of the utility, we added another measure, which is the happiness indicators. The idea is that happiness is similar in concept to utility. So happiness indicators could be useful indicators of utility. They could give us additional information about the utility. So this is the happiness model equation. So the happiness with alternative I is a function, some function of the utility of I plus a measurement error term, VI. We have applied this before to mode choice models, but in this particular study, the application is to activity pattern choice. So we use the activity-based model of Denver, Dr. Cog, and it follows the typical day activity schedule that's often used in activity-based models in the US, where we have an activity pattern model, which basically structures the day into different tours and activities. And then conditional on that activity pattern, the details of the tours and trips are modeled, like the destinations, the modes, the times of day. There's also some feedback from that into the activity pattern through log sum terms. In the case of the Denver model, the activity pattern in particular was defined as the number of home-based tours. So a tour is a sequence of trips that starts at home and comes back home. So the number of tours that the person conducts on a given day, whether it's 0 tours or 1 or more tours, by purpose. And the number of secondary stops, any additional stops that the person made, also by purpose, 0 or 1 or more. There are 7 purposes modeled, activity purposes. So as an example of a pattern, you may on a certain day do 1 or more work tour, 1 or more shopping tour, and 1 or more secondary stops, which are of the type escorting somebody. So given all these different purposes and potential combinations, we have a total of 2080 activity patterns after some simplifications. So what we want to see here is we want to see if this framework applied to activity patterns can result in better activity pattern choice model. So we added a satisfaction question to the Denver survey. The Metropolitan Planning Organization, which is called Dr. Cog, they agreed to add a satisfaction question to their survey back in 2010. And the measure was, it's a bit difficult. I mean, we want to add how happy you are with this pattern. So you see it involves different tours, stops, etc. There may be patterns where you don't do any travel. So we want to account for all that. So we asked this question for the well-being for the chosen pattern. Thinking about yesterday, how satisfied were you overall with the way you traveled, the places you went to, including staying at home, and the things that you did at these places? And that was answered on a 7-point scale from very dissatisfied to very satisfied. And we also asked about the deviation of the chosen pattern from plans, whether the person changed their travel plan as the day progressed compared to what they had planned before, yes or no. And I will explain why we asked that. So we call that E, measure E. So this is the same framework I showed before, but now the utility is the utility of an activity pattern, and the happiness indicator is only for the chosen pattern. It would be definitely infeasible to ask about the happiness of each of these 2080 activity patterns. So we only ask about the happiness for the pattern that was actually chosen. So how would the happiness model then change compared to what I showed you before? So this equation, HI equal H of UI plus VI, is available only for the alternative that was chosen, meaning yi equal 1, and only if the pattern happened as planned, meaning the response to this E question here is no, meaning the person did not change their plan. Why is that the case? It's because the happiness response is obtained retrospectively after the pattern was chosen and experienced, after the day has ended, because we're asking about, for example, the previous day. While the utility here is a decision utility. So the person tries to predict the utility from different activity patterns. So it's made in a predictive sense. So if the pattern happened not as expected, there would be a deviation between the retrospective happiness measure and the predicted utility. So we use it as a measure of the utility only if the pattern happened as planned. Just to show you what we got, we estimate the model and then we try to compare this model with happiness to the model without happiness. So the model without happiness, meaning just this one, we call it the standard model, and the model with happiness, we call it the extended model. And we estimate two versions of the standard model, a logit model and an error component logit, like a mixed logit, because in the extended model, we include error components. So we use two metrics to compare the model performance. The first one is goodness of fit through the choice log likelihood. So we find that the model with happiness, this is the choice log likelihood, the log likelihood of the choice only, not of the happiness. We find that the choice log likelihood is worse, and this is more negative in the case of the extended model compared to the standard model. So it seems the standard model fits better the choice data. And this could be because of potentially overfitting of the original model. There are many variables included in the systematic utilities related to the activity purposes and combination of purposes and so on. So there could have been a potential overfitting of the original model. It could also be because this extended model optimizes the log likelihood over both the choice and the happiness data, while the standard model only optimizes it over the choice data. So it may perform better in that regard. The other metric we look at is efficiency through these three indicators. Efficiency refers to how accurate the parameter estimates are, the betas of the model. So a more accurate parameter would tend intuitively to have smaller standard error. So we find that there are different ways to measure that. One is taking the difference between the variance covariance matrices of the two models, the standard minus the extended model. And if the difference of the variance covariance matrices is positive definite, it means that the extended model is more efficient. We did not find evidence here that it's positive definite, but the other metrics that we used, which are the trace of the variance covariance matrix and its determinant, turned out both to be smaller for the model with happiness compared to the model without happiness. So if we compare this, for example, to this and this, we find that it's smaller, similarly for the determinant. And when the trace and the determinant are smaller, these are indicators of a more efficient model. So to summarize, we did not find evidence for better goodness of fit, but we find evidence for gain in efficiency when we add these happiness indicators to the choice models. And I would just like to mention that these happiness equations are only added at the stage of model estimation to get the betas in the utilities. We do not need these equations when you want to apply the model for policy analysis, for example. So they're only used to get more precise betas. And once you have more precise betas, you can use them to do policy analysis as usual with the choice model alone. Okay, so this was it for the three studies, and I will just conclude with two slides. The first one is about the main takeaways. So in terms of measurement, one question that comes up, especially in relationship to the second study, is when should we measure happiness if the real-time measures may give us different results from the retrospective measures? My opinion on that is that both measures are useful, and it depends on the purpose. So for the real-time measures could be useful, for example, for improving the user experience. If we're able to get, say, real-time measures of, say, drivers' stress while driving, or people's experience on public transportation during the experience itself, that can help us try to improve the user experience. Retrospective measures, on the other hand, could be useful, for instance, for predicting future behavior. It has been found in several studies that people often tend to repeat behaviors that they remember as, say, more pleasant. So retrospective measures could be useful in that regard for choice modeling and prediction of future behavior. In terms of modeling, as I said, satisfaction indicators may increase choice model efficiency. So it may be useful to add some satisfaction questions to surveys, typical transportation surveys, which anyway tend to be very long. So adding 1 or 2 more questions could result in potentially better choice models. And finally, for policy in particular, as related to the first study, the policy implication is to encourage maybe public transportation free trials, to encourage people to use public transport as a regular commuting mode, even and potentially in context with informal public transport, like the case where the study was done, as well as another policy implication for public transport operators is to improve attributes of the service that are most correlated with satisfaction with public transportation. Finally, some potential directions for future research in this field. In terms of measurement and modeling, I think the field would benefit from more dynamic assessments of subjective well-being in transportation. Most studies have relied on static or cross-sectional measures of subjective well-being, naturally, because dynamic assessments are more difficult to get. But the field, I think, would benefit from having a better understanding of happiness through dynamic assessments. Another interesting direction, I think, would be to combine subjective well-being self-reports. This is typically the norm in these studies where people report their happiness, to combine these measures with other maybe objective or passive measures. What do I mean here? For example, physiological measures of stress, let's say trying to measure heart rate or heart rate variability while driving, facial expressions as indications of happiness, or even doing sentiment analysis of texts that people write, say, on social media. So this could provide potentially useful measures of happiness that could be combined with self-reports. In terms of applications, there have been a lot of studies on how happiness varies with different modes of commuting, mostly standard modes. I think it would also be interesting to measure the influence of emerging mobility services, like say ride sourcing and micromobility, as well as new technologies like automated or conditionally automated driving on subjective well-being, and to better understand the influence of telecommuting on subjective well-being. And this is obviously inspired from the recent COVID lockdowns and the increase in flexibility in working at home. And finally, it would also be beneficial to have more evidence-based studies from a policy perspective for the impacts of transportation policies on subjective well-being. So these are just some thoughts for future research. And with that, I conclude the presentation. Thank you so much for listening.
Thank you very much for that wonderful presentation. We have approximately 50 minutes for questions, so feel free to post your questions on the chat box. As an icebreaker, I'm going to start. So thank you very much. The first picture you showed about the transit in Beirut remind me a lot about the transit situation in my hometown of Santo Domingo, Dominican Republic. So I was wondering, like, how would you think variables related to like comfort, quality of the vehicle, safety might have affected transit commute satisfaction? Because it seems to me like, especially for people who drive, they said like, as soon as I have a car, I will never use transit again, right? So
yeah, you are right. It's difficult, I mean, to capture these variables. I think they would be to measure them in the survey. They would be accounted for through the constants, or in other words, the threshold parameters that were estimated to capture this, I mean, the effect of these other unobserved variables. But yeah, that's definitely an important point to account for. Most public transport users tend to be captive users of the system, but still, I mean, there are a lot of misperception, I think, in that particular context about public transport. There are a lot of unawareness. People don't even know which bus lines pass near their house or university. So there's maybe a bit of both.
So I wonder, like, if you had like a more even playing field, like a country where transit was actually higher quality, like how the results will differ?
Yeah, that would be interesting to compare. But there have been studies. I think there was one study done in Sweden, which I think tracked some people who changed public transportation, who changed commuting mode to public transport. And they found similar conclusion in that context, that people's satisfaction with public transport in real time tended to be different from what they actually remembered. So But it has, like, of course, this has to be replicated in other contexts to make a more solid conclusion about that.
Thank you. So are there any questions for Maya? There's a question from Ellie. So great presentation. She was wondering if the reference points matters in this case.
In which study, Ellie, in the first study you're mentioning?
Yes, Maya, in terms of the happiness, because, you know, when you think about like people, what was the reference point that they kind of, you know, indicated? I think, you know, different.
For study 2, the second study. Yes. They did not indicate for us a reference point. We modeled the baseline level of happiness as the median of the reported activity happiness. One can potentially model the set point as something else. Maybe it could be treated, for example, as a latent variable or something else, but they did not report it themselves in the survey. In the literature on the hedonic treadmill, typically they tend to take the median also as the set point, and in some cases they use like a moving average that it could change. But in this case, we did not use a moving average because of the brevity of the data collection period.
Yes, okay, great, thank you. Thanks.
Thank you. I have a question from Anisha. Hi, Anisha. First study, how do the observed compare to the predicted H1 and H2? Yeah, good question. I did not show it in this presentation because to save on time, but we also did compare the observed measures, whether they significantly differ from the predicted ones, and we reached almost the same conclusions doing that as well. So what is the benefit of comparing the predicted H1? Why do we compare? Yeah, just to be consistent. We did the predicted ones because the H3 is predicted. We don't have an observed H3 for the car users. So we just to be consistent, we also got the predicted H1 and H2, but doing the same test of comparing the observed H2, for example, versus the predicted H3, we reached the same conclusion of significant difference.
Great. Are there any other questions? Yeah, they have another one there.
That's a great question. No, I did not think specifically about an overall framework here. It depends on framework for doing what, but obviously equity is a very important measure to account for as well, if you mean in terms of its relationship to happiness, or so definitely, I mean, equity should be accounted for in terms of its relationship to subjective well-being overall. In these different studies that we have worked on, we did not study equity in particular, but I think, for example, in the last slide where I mentioned some potential directions for future research, there have been some studies on, say, how right sourcing could influence, could reduce potential inequities, and that's obviously related to subjective well-being. So this is definitely one step in that direction. Thank you.
Thank you very much. Any other questions? Okay, well, the audience writes, I have another one. So I'm going to post it in the chat just in case, but I was curious because you showed that in the third analysis that you gain efficiency in terms of parameter estimation, but then you also lose at least goodness of fit, right? So for predictive purposes, you would assume that the traditional model will be better. So in that case, how should analysts make this trade-off between efficiency and predictability?
Yeah, that's a great question as well. I think maybe we're losing goodness of fit, but we're gaining efficiency. I think one maybe measure that we should also look at, which we did not do here, is we looked at the goodness of fit using the estimation data set. I think what would be good to do is to do a predictive goodness of fit, maybe keeping a holdout sample and seeing how that would do on a holdout sample to resolve that question.
Okay.
Yeah.
Thank you. So we still have 7 minutes left. So any questions, comments?
Is there anyone in the audience working on subjective well-being or?
Oh, that's a good question. Maybe Professor Omori from Utsunomiya University used to work on that. Oh, there's a question, how does this relate to decarbonization?
That's maybe the tough question to answer. I don't know. It's in relationship, for example, to the first study. This first study, as well as previous studies that I have done before, where we tried to also give free public transportation trials to people to see if their mode choice would change. We recruited a sample of car users. We did a natural experiment, and we wanted to see if they would change to public transport and how that ties into their happiness. So in that sense, I mean, if we can have a better understanding of how happiness varies by mode and what are the different factors that could increase satisfaction with public transport, that somehow could be tied with behavioral programs to shift people towards public transport and to have some impact in that regard. I'm thinking that we need mode shift, that people might not be happy with our sense of well-being when moving on.
Yeah.
Excellent. Yeah, in relation to that as well. Yeah, of course, I mean, the shift should not be, forced on people. Obviously, people may feel a reduction in their well-being. For example, if they shift to the car, to the public transport, they may lose, say, the flexibility of using the car. And there have been some studies that mention this point, that they may have a reduction in well-being in that regard. But in that study we did at MIT during my PhD dissertation, we did subsequent analysis of the sample of users that actually ended up switching to public transportation. I have a paper on that with Professor Fuji, and we found that that particular sample that switched ended up being more satisfied with their commute by public transport compared to their initial level of satisfaction with the commute by car. So when the switch is voluntary, it's not mandated. I do not think there will necessarily be a reduction in satisfaction. We expect an increase in satisfaction. So I don't think it has to be voluntary, basically. Maybe through some nudging by regulation or operators or others.
Was that mentioned, the one you mentioned about Professor Fuji was in Kyoto? Because I read he wrote a paper saying that showing the same bias that drivers have a worse opinion than reality about the bus service in Kyoto, but when actually experienced it, actually their opinion was so much better than they thought it was.
No, that was still, our study was not in Kyoto. It was still using this MIT data that I did during my PhD work. But we did further analysis, me and Professor Fuji, about that using that particular data. And this was the conclusion we found.
Okay. There is actually one more question there regarding how subjective well-being can be related to transport equity. It's the third one from the bottom.
Yeah. So, I mean, there has been some research that shows that in societies where there are higher degrees of, not transportation, but in general, inequities, subjective well-being tends to be lower. For example, in places where there's a high degree of income inequity, there will be lower degrees of happiness or satisfaction, even at the national level. And that's why actually some of, for example, the Nordic countries tend to be among the happiest in the world, because I think there are less degrees of inequity in society in general. In terms of transportation in particular, I mean, when higher degrees of transportation inequities could lead to lower degrees of subjective well-being, at least for the people that are impacted by those inequities. So there has been a lot of research. I mean, it's not called necessarily subjective well-being in particular, but there's a large literature on social isolation and social exclusion, and that really ties directly to that, I think. I have a question from, we need mode shift that people might not be happy with. This I answered already, okay. Is there good reference material that relates satisfaction with well-being? That's true. That equates satisfaction with well-being. Yeah, maybe I have used some concepts interchangeably here. So the way I defined it on the first slide, subjective well-being, that's also actually known as hedonic well-being, that definition that I used, because there's also eudaimonic well-being, which I did not refer to in this presentation. But that notion of hedonic well-being, subjective well-being, includes two components, which are satisfaction, which is the cognitive component, which is when we do a global assessment of our lives, and there is the affective component, the emotional part. So satisfaction is not really the same as well-being. It's just one component of it. It's the cognitive component.
Okay, I think we have time for the last question right there, and then we'll wrap up the session.
Okay. Relating satisfaction, any large-scale studies of how electrifying. Interesting. No, I'm not aware of any such studies actually, but it would be interesting thing to look at. Yeah,
okay.
It's definitely interesting. Yeah.
Okay, Maya, thank you very much for joining us. And
thank you all so much
the
for the
audience.
discussion, and thank you again, Giancarlos.
And then I think the next session we share by Ellie is about pedestrian, urban mobility, and land use impacts. And then on the parallel session, transportation planning and policy analysis, led by Dr. Shikara from Hiroshima. So let's split up, and thank you very much for joining.
Thanks.
Thank you, Maya.